This is a P5 video from the topic forces, looking at two equations about pressure. And this first equation, pressure equals force divided by area, we can first of all start thinking about a drawing pin. The flat part of the drawing pin that you push your thumb on has a larger surface area, therefore it spreads out that pressure across your thumb so it doesn't hurt. The force that it is exerted, it just depends on the force of that particular person. If you want to exert more force, you might use a different person, or you might use a hammer or something like that. So let's say the force stays the same. The pointy part of the drawing pin has a smaller surface area, and that focuses all of that pressure into one point. So we can say if the area is increased, the pressure is decreased. If the area is decreased, the pressure is increased. So that's one way we can look at that. Things like sharp knives, okay, they're going to reduce the area, therefore increase the pressure. Pair of skis are going to increase the area, therefore reduce the pressure. Now I'm looking at a difficult question using a hydraulic system. Hydraulic systems are used in the brakes in the car, and that's the example we're going to look at. So hydraulic systems have two pistons or cylinders. Here we've got one where there is a force going into it. Okay, we call this the master piston or the master cylinder. And over here we have the slave cylinder or the slave piston, which is going to be doing all the work. And it's an example of a multi-step calculation because we've been told that a force of 20 newtons is applied to the master piston. We're told that the area of the master piston is 0.2 meters squared. That could be in centimeters squared, and you may have to do a conversion, but I've kept it simple, meter squared, meter squared. And then we've been asked to find out the force exerted by the slave piston over here, knowing that the surface area of the slave piston here is 0.7 meters squared. So we've got to first of all find out the pressure here. Okay, so we know we've got a force of 20 and a surface area of 0.2. Now pressure, using my formula triangle, is force divided by area. The force is 20, divide it by 0.2 gives us a pressure of 100 pascals. We could say it's a pressure of 100 newtons per meter squared, but we can also say 100 pascals. Now, because this liquid in here is incompressible, it can't be compressed, okay, it's probably an oil, there's no change in pressure through this system. So we can use our answer for pressure here, and we can use it in our second calculation over here to work out this force. So we know that the area on this piston here is 0.7 meters squared. They told us that. Using that and the pressure that we found, we can work out the force. Go back to my formula triangle. Force is pressure times area. Okay, and the pressure was 100. The new area, 0.7. Okay, multiply those together and we get 70 newtons. So 20 newtons goes in and 70 newtons is exerted by the slave piston, comes out of it. So with a relatively small force, the force of us pushing our foot on the brake, we can get a big force in the brake discs of the car. So that's our first look at the first equation. Pressure is force divided by area. Let's look at our second pressure equation. This is pressure in liquids, okay, looking at how the density of the liquid that the object's in and the height at which, so that the depth it is, and how gravity all affect the pressure applied on that particular object in the water. So I've got our formula triangle down here, slightly more complicated than previously because we have 4 different variables, okay? This symbol here is the symbol rho, and this is for density, okay? So we've got height, density, gravity, and pressure. And it says calculate the change in, so we're looking at a difference here, in pressure of a point 18 metres below the surface of the water and 34 metres below the surface of the water. So we need to find out the pressure at 18 metres, the pressure at 34 metres, and then the question says the change in pressure, so we need to work out the difference between those two. And they've told us the density of water is 1,000 kilograms per metre cubed. If this was in oil, the density would be different, so you may have to compare something that's in water and then in oil, and you might get a difference that way. But this time, they've chosen not just to find out the pressure at one particular point, but to see how much the pressure changes between 2 given points. So to make that easy to kind of follow through, I've written pressure at 18 metres and then pressure at 34 metres. Now I don't have to rearrange the equation, so that's quite handy. I've got my 18 metres, my density of water, and gravity. They will assume you can remember it's 9.8. You will not be given that fact in the exam, okay? So you'll be thinking, but I've got too many unknowns. It's because you need to remember for yourself that gravity is 9.8 newtons per kilogram. So we've got all of our units in the correct units. There's no changing needed. So 18 multiplied by 1,000 multiplied by 9.8 gives us this big number here, 176,400 pascals. And that's the pressure at 18 metres. Then we look for the pressure at 34 metres. Same situation, except this time we've changed to 34. So we work out the pressure to be 333,200 pascals. So I now know the pressure at 18 metres, I know the pressure at 34 metres, and I now need to work out the difference in pressure. Okay, how much more pressure is there if I go to 34 when I started at 18 metres? So for this one I've done pressure difference, and I've taken the pressure at 34 metres, subtracted the pressure at 18 metres, and I found the answer to be 156,800 pascals. And then for completeness, just in case this is what they're looking for, I've changed it to kilopascals, 156.8 kilopascals. Okay, that I think is one of the hardest questions that you may have looking at this, where you've got one situation, another situation, and it's finding the change in, rather than just a straightforward what's the pressure at 18 metres. Okay, hope you found that useful. Thank you.